Vaccines are all the rage here in 2021. Usually when you get a vaccine, they jab you in the arm with a needle, give you a piece of candy, and send you out the door. But what if that piece of candy was actually your vaccine? I'm working on a vaccine technology that could eliminate the need for needles by repurposing a bacterial toxin. Bacteria are brilliant. Over centuries, they have evolved these little proteins that can penetrate one of our best defenses, our mucous membranes, and I want to harness that ability. I study A/B toxins, illustrated on the left of my slide. These have a binding or a B subunit, and this is where the magic happens. The B subunit binds to a cell within a human or animal's mucous membrane, and that binding event allows the toxin to enter the host cell. They also have an active or A subunit. Once the toxin is inside the cell, the active subunit has a toxic effect. You know that massive watery diarrhea that happens with cholera infections? That is the handiwork of the active subunit of cholera toxin, the most famous AB toxin. So I'm part of a team, and in our lab, we are repurposing cholera toxin. We're trying to harness that ability to penetrate mucous membranes. So we cut off the toxic A subunit and replaced it with a protein from a different microbe. We did this to address a specific disease that affects dairy cattle. Staphylococcus aureus, or staph for short, causes mastitis, an inflammation of the udder that's really painful for the cows. It ruins their milk, and it costs the global dairy industry about $2 billion every year. In places where people rely on a single cow or a small herd for subsistence, losing a cow to mastitis can be devastating. So preventing staph infections through vaccination could have a big global impact. Okay, so to create our vaccine, we cut off the toxic part of cholera toxin and replaced it with a staph protein. This modified protein is our vaccine. Now remember I said that the binding subunit helps the toxin to enter the host? Since we kept that part intact, we can deliver the vaccine simply by applying it directly to a mucous membrane, so no needles are required. We tested our vaccine in a clinical trial with cows who hate needles even more than you do. We immunized the cows through the mucous membranes of their noses, and we got positive results. The vaccinated cows did launch an immune response against staph. And we proved that these toxins that have been evolutionarily crafted and perfected by bacteria over centuries can be repurposed for our own use. If the staph vaccine works for cows, we could transition it into a human staph vaccine, like for MRSA. And in theory, we could put any protein from any microbe onto that cholera toxin backbone and end up with a needle-free vaccine. We could even use the spike protein of the COVID-19 virus. Whatever we attach there, again, we don't need needles to apply it. Imagine if you could skip the needle jab and eat your vaccine in a piece of candy instead.